takeoff and landing phases of an aircraft's flight are critical moments, often considered the most challenging and vulnerable in aviation. These phases are where the majority of pilot-caused aircraft accidents occur, highlighting the significance of understanding the variables that affect an aircraft's takeoff and landing performance. Whether it's the transition from a standstill to becoming airborne or the delicate touch required to safely touch down, the pilot's mastery of these phases is so important. Takeoff and landing performance encompasses a complex interplay of factors, including aircraft weight, atmospheric conditions, runway surface, gradient, and pilot decision-making. In this exploration, we will dive into these key aspects that shape an aircraft's takeoff and landing performance and emphasize the critical importance of precise professional procedures during these crucial phases of flight. Takeoff performance. Takeoff is a dynamic process involving accelerated motion, transforming an aircraft from a state of rest to the takeoff speed necessary for liftoff. Central to this process is the takeoff speed, which is inherently linked to the aircraft's stall speed or minimum flying speed. A heavier aircraft requires more energy and a longer distance to accelerate to takeoff speed. A key factor in determining takeoff distance is the aircraft's gross weight, which directly affects the liftoff speed. An increase in weight results in the need for a higher speed to generate sufficient lift, thereby prolonging the takeoff distance required. Runway surface and gradient. The runway surface is a critical factor that directly impacts an aircraft's takeoff and landing performance. While performance charts typically assume ideal conditions of paved, level, smooth, and dry runways, the reality can be quite different. Different airports may have runways composed of various materials, including concrete, asphalt, gravel, dirt, or grass. Runway surface variations can introduce complexities such as reduced traction on soft or muddy runways and the potential for tire damage on rough surfaces. Additionally, runway obstructions like snow, water, or standing water can significantly hinder an aircraft's acceleration during takeoff and braking effectiveness during landing. Braking effectiveness in particular is a crucial consideration, and a pilot must be aware of runway conditions to make informed decisions for safe takeoff and landings. Water on the runway and dynamic hydroplaning. Water on the runway poses a significant threat to takeoff and landing performance. When water accumulates on the runway surface, it reduces the friction between the aircraft's tires and the ground. This diminished friction can lead to hydroplaning, a condition in which the aircraft's tires ride on a thin layer of water instead of gripping the runway. Hydroplaning severely compromises braking effectiveness, resulting in longer takeoff distances and potentially dangerous landing conditions. Pilot awareness of these conditions and the ability to make rapid decisions to adapt to changing circumstances are vital to ensuring safe landings and takeoffs. Takeoff and landing performance are high-stake phases of an aircraft's flight, and their successful execution demands precision, knowledge, and effective decision-making. The mastery of these skills ensures that an aircraft takes flight smoothly, lands safely, and keeps passengers and crew secure, underscoring the pivotal role of the pilot in the world of aviation.